Okay, good.
Miss
Murat,
Mr.
Ayan, Rifa. Good to see you again. Yes, Murat. Or Rifa,
No,
who
I
is?
just want to say like hello, like because like you did not answer in the beginning.
Okay,
Yes.
okay, guys. If
Yes.
possible, if possible, turn on your camera. Okay. Sometimes if you need to go out at that time, you can turn it off. If possible, turn on your camera the whole class. So I want to see your faces.
Unfortunately, right
This will
now
be
I'm
much
not at my
better.
house and I'm on megabytes. So today I can't. Like I'm on megabytes. I have like 300 megabytes
So 300 megabytes is enough for 1 hour.
with camera.
Yeah.
Are you sure? Okay. But like if it will finish, it's not like my problem.
Okay. Because usually I also always use 4G, my telephone. So in like 1 hour, it just consumes like 145 or 200 megabytes, something like this.
Oh, because you're like in Cambodia, I think like it gets it takes less because in Azerbaijan it takes 800 megabytes for 45 minutes.
Oh, I see. I see. I don't know, Murad, you
Because
should try because this Zoom is a bit different. Okay, in Zoom, it doesn't consume much. We should try. Maybe
yeah,
not this,
sure, sure.
not this time. Next time when you have more megabytes, you have to try. Of course, in other countries, I don't know. In Cambodia, our internet connection is very, very good, and it's very. I mean, the speed is very high.
No, here is very really bad. It's really really
It
bad.
is really good.
I don't know why is it so. These countries. Anyway, guys, good to see you again, Ayan. Welcome, Murad, Rifa. So last time we were studying, am I recording? Okay, yes. So guys, we started expansion and factorization of algebraic expressions. Okay, if possible, all right. Also keep your microphone on because I want to work together with you. Okay, if I only talk, these things I think you know somehow, but actually we are going to practice together. If you remember, what did we learn last time? We learned this expansion of algebraic expressions, the first one, and after that, perfect squares and difference of two squares, right? And today we will learn factorization of algebraic expressions. This is a little bit more challenging, but it's not so hard. Okay. Again, last time factorizing, right? Factorizing, if you remember, what does factorizing mean? We learn have to, what is it, right? Algebraic expression, right? As a product of simpler algebraic expressions. And also last time we practiced expansion, but today we are going to learn factorizing. As I say here, factoring and expanding, they are just reverse operations. First, if you expand, after that, now by factorizing, we can just write it as a product of maybe numbers and the algebraic expressions. Why is it important? It's very important in solving a lot of mathematical equations because you know that solving equation is the biggest task in math, right? Every time you're solving a problem, you have to model this and you get an equation, then we have to solve this. Now, how do we solve the problem? We have different techniques, right? By factorization, by using formula, by using geometry, it's graph, we have numerical method, different methods. But one of the most commonly used method is factorization method. That's why you should know very well how to factorize algebraic expressions. Okay, let's just do this. One thing is, for example, a times x plus b times x here, right? As you see here, each term contains the same letter. What is it? It is x. We call this a common factor. So I can just take this out. I can factorize that x times a plus b. And how about if we have three, for example, let's say a times x plus a times y plus a times z. Rifa, what is the common factor here?
A.
A is a common factor. So I can just take this out, right? So here we have x plus y plus z. So what we have done here is we have factorized the given algebraic expressions. This one is the first one, right? This one is the second one. And here we just have an algebraic expression. Now we have just written down as a product of two things here. That is what we call factorization. Ayan, let's start with you. Not Ayan, Rifa first, then after that Ayan, after that Murad. Okay. Rifa, can you factorize this? What is the common factor of 2 and 6x?
was two.
2, right? If you take 2, okay, continue. What
It
should I
was
write here?
2,
1.
1 plus 3x.
Very good. Immediately just check this. 2 times 1, 2, 2 times 3 is, it is 6x. Ayan, how about question B?
It will
What is
be
a common factor?
5.
5. 5 is a common factor. Okay, here we have
X plus 3y.
x plus 3y. Murad, how about C? What is a common factor of 3x squared and 9x?
3. 3.
3, 3 or 3x?
3. 3x. No, just 3.
3x. Because as you see here, 3x squared
Yeah.
plus 9x, right? I can write it
Yes.
as 3x times x. And second one is 3x times 3.
Yeah. Okay. Yes. 3x. Yes.
So if we just take 3x out, what do we have in the brackets?
So I think here we have like x plus wait 3 wait yeah 3.
3, right? Because 3x times 3
Yeah,
is
yeah.
9x. Very good. Rifa, can
Yes.
you factorize question D? What is the common
Yes,
factor?
2. 2p.
No.
2p. 2p.
2, we have 2. How about pi? We have pi. How about r?
R also, yes.
Also, r is a common factor, right? The common factor here is 2 pi r. So if you just take 2 pi r out, what do we have?
Plus h.
R plus h.
Yes.
Ayan, are you familiar with this formula? Question D, did you ever say this before?
Not exactly this formula, but I'm familiar with pi.
Okay. This one is, soon we will learn this, actually we will use this. That is the total surface area of a cylinder. You know what is a cylinder, right?
Yes, we do.
Now, if you have an A4 size paper, right? I don't know if you can see me. A4 size paper, you just fold this, you can make a cylinder, right? If you just unfold this, if I unfold this, what we have here, we will have something like this. We will have a kind of rectangle, right? And at the top, it is just closed by this circle, and the bottom is closed by this circle. And all this area together, actually, that's equal to, because this circle, what is the area of the circle? It is pi r squared. And how about this one? Also, it is pi r squared. Now, when I unfold this, actually, as you see here, the circumference of this circle is the length of this rectangle, right? So what is the length of this rectangle? It is 2 pi r. And how about the width? Actually, this width is, it is the height. That is the height of the cylinder. So we know that to find the area of the rectangle, we need to multiply its length by its width, right? Anyway, that is just the formula. Here, E, Murat, can you factorize question E? What is a common factor of these terms? How many terms we have? We have 3, right? 1, 2, 3. What is the common
Question
factor?
E.
Yes.
So the common factor is 2.
Are you sure?
No, 2y.
Very good. 2y, right? Every term has 2, every term has y. So 2y is a common factor.
Yes.
Now, what should we write inside the parentheses? Can you tell me?
Yes, 2x.
What? 2 is
Actually,
already
no.
outside.
Yeah, yeah, I'm sorry.
Only
I'm saying
x.
x. Yes,
Okay.
x.
Plus.
Plus y. Wait, yeah, 2 z.
Okay. Minus.
Minus also like 2.
4, because if you take 2
4.
from 8, 4 is
2.
left.
Okay, yeah. 2. Yes, 4. X z.
X and Z. Okay, Murad, I think you need to practice more. Okay, you should
Yeah.
read a bit fast. Guys, let's continue. Now, as you see here in the previous examples, we had only 2 terms or 3 terms, right? And how about if we have 4 terms? How can we factorize it if factorization is possible? One method is we have to group them, okay? So we have to group, for example, if I group these 2 as 1, these 2 as 1, and after that, we know how to factorize each group, right? In the first group, A is a common factor. Take this A out. So here we have B plus 4 plus, how about in the second group? 3 is the common factor. Here we have B plus 4. If it doesn't work, you have to regroup again. Take the first and third term and second and fourth. So as you see here, b plus 4 and b plus 4, it's a common factor. Now, as if we have something like this, a times x plus 3 times x, right? I can write it as x times a plus 3. What is our x? That is b plus 4. So take this b plus 4 out. Here we have b plus 4. What is left in the first term? Here we have a. From the second one, here we have plus 3. Okay. Ayan, can you do question B? So let me just group like this, right? And like this. So what is a common factor in the first group?
X.
X is a common factor. So here we have x plus y. And how about in the second one? What is a common factor?
-3.
Very good. -3 is a common factor. So here we have x plus y. Now, as you see here, we have two terms. X plus y is a common factor. X plus y. And here we have x minus 3. Murat, how about question C? From a squared minus ab. Let me just do a group like this and
Yes.
this one, right? A squared minus ab. What is a common factor?
A.
A. So if you take this a out, here we have a minus b. How about the second one? What's the common factor?
2.
Okay, plus 2, right? If you just take plus 2 out, what is left here? Minus b and
Minus.
plus a.
Yes, Mister,
And
you're like telling me to practice, but you're not letting me solve. Like you write instead of me. Can I just answer myself?
yeah, Murat, but you should be a little fast, okay?
Yes, sure, Mister.
Good.
I'll be faster, but please don't answer instead of me.
Okay, Murat, what is minus b plus a?
Minus BA? No,
It is
wait.
a minus b.
Oh, A minus B, okay.
Because here, minus b plus a equals a minus b. Instead of this minus b plus a, we can write it a minus b. So now here we have a minus b, a minus b. So what is the common factor, Murat? Tell me, what should I write next? So we have to factorize it, right?
So A minus B, like
That's
in general.
correct. Okay. Then?
And 2.
No,
No.
Murat, look at this. What do we have here?
A, yes. I'm sorry.
Okay,
A minus B again? No.
look at this number. What do we have here?
2. Then okay,
Plus
A
2.
plus 2.
Yes, a plus 2. Rifa, question D.
Yes, okay. It will be x.
X
No.
cubed minus x squared. What is the common factor?
X cube. No.
Squared.
Just x.
X squared.
Oh,
Very
okay,
good.
okay.
X squared is a common factor. So here we have x minus 1. Again, using this Rifa, we can just write minus 1 plus x as x minus 1, right?
Okay.
So I'm just going to write this. Here we have x minus 1. Yes, Rifa, continue. What is the common factor here?
In like first one, it's 1.
No, what is the common factor of these two expressions? X minus 1, right?
Yes, x minus 1.
Okay, that's x minus 1. Just take this out. So what is left here? What should I write here?
X squared.
So here we have, right, x squared left. So x squared. If you take this out, how about here?
Minus 1.
Plus 1. Why do you write minus? Here we have plus.
Yes, okay.
Plus 1. Ayan, last question for you. Ayan, what color do you like?
Purple.
Purple. Okay, I will choose purple for you. All right. Equals, what is the common factor?
A plus 2b.
Very good. A plus 2b. Because here we have a plus 2b squared, and here we have a plus 2b. If I just take this out, what is left here, Ayan?
3a minus 7b.
Say louder. What is it?
3a minus 7b.
No. You're just taking one out, right? Because here, what we have here? Here we have a plus 2b squared. I mean, actually that squared means a plus 2b times a plus 2b, right? minus, and the second part is a plus 2b, and here we have 3a minus 7b. And now you are saying that this a plus b is a common factor, right? So if I'm just taking this out, if we just take this out, a plus 2b, okay? Now what we have here, if we just take one out, one is left here, right? So here we have a plus 2b. Now what we have here, our sign is minus. Now I have this expression. So that is what we have here, minus 3a minus 7b. That is equal to minus times 3 minus 3a minus minus plus 7b. So here we have minus 3a plus 7b. Is it clear, Aya?
It's a little confusing, but most of it is clear.
Okay. So now the rest is we have to simplify. Because here instead of, we don't have x. Instead of x, we have one expression here. That's why maybe a little bit confusing. So a plus 2b, and I have to simplify the second part. A minus 3a, that is minus 2a. 2b plus 7b, that is plus 9b. Okay? All right. So guys, now we will study a little bit different thing, the special case. So Rifa, in our last example, we studied these things, right? What is this, Rifa? It is a perfect square. Why? Because we can write it as a square of a plus b, or just one algebraic expression. And also this one, if it is in this form, that a squared minus 2ab plus b squared, which means that it is a minus b squared. And how about the difference of squares of two numbers, that is a squared minus b squared, a minus b times a plus b. Okay, we have already learned this. So now we have to factorize the following. Also, this one is already factorized form. That means that a plus b is multiplied by a plus b, right? That's why in math, if something is multiplied by itself in just compact form, we can write it as a squared. This a squared means also it's in factorized form. Okay, now here x squared plus 6x plus 9. As see here, I can just write it as x squared plus 2 times 3 times x. And how about 9? I can write the 9 as 3 squared, right? As I see here, actually it just matches exactly with this formula, right? The first formula. So that means that that's just equal to x plus 3 squared. So we have just factorized this. Of course, in another way we can do this. And how about the second one? T squared minus 12 in the formula. As you see here, always we have 2, right? So negative 12, I can write it as 2 times 6 times t. And how about 36? 36 is 6 squared. So now again, it matches with the second formula, right? That means that it's just equal to t minus 6 squared. Murat, is it clear? Do you understand this?
Yes. Yes, I
Very
can
good.
understand.
Very good. And the second one, how about k squared minus 81? We have two numbers and both are squares of something, k squared. 81, we can write it as 9 squared. So we know that it's just, we have already proved that if you are given a squared minus b squared, that's equal to a minus b times a plus b. So I can write it as k minus 9, and here we have k plus 9. Ayan, can you factorize D? Ayan Nagizade. Ayan, am I pronouncing your name correctly?
Well, yes, but for my last name, you can just say it like Nagizade. But yeah, you're right.
Nagizade. Okay, I'm just calling you not with your surname because otherwise you may get confused with second Ayan.
A second Diana is not here.
Oh, she's
Oh
here. You
no.
gonna see her?
Yeah, she's here.
Ayan, are you there? Yeah, maybe. I don't know. Yes, Ayan Nagizade. How do we, can you factorize this? 9a squared minus 4.
3a squared minus 2 squared equals, I think it will be 3a minus 2, 3a plus 2.
That's right, because 9a squared, I can just write it as 3a squared, right? Minus, how about 4, 2 squared. Now it's in the form of a squared minus b squared. So that's equal to 3a minus 2. And here we have 3a plus 2. So we have factorized this. All right, let's continue. Evaluate the following by factorization. Okay, that is one using algebra, a lot of multiplication we can do mentally very quickly, because every time using calculator is weird, right? Since we can do that, right? We have brain, we have to use it. And sometimes I see people, you go to bazaar or market, you're just buying like 2 kilos of potatoes, 3 kilos of, let's say, tomatoes and some onion, and the price are very simple. And here, 1 kilo of potato, let's say this $2. 1 kilo of tomato, let's say this $2. And if you're buying 2 kilos or 3 kilos, you should be able to do this mentally, right? And maybe a lot of people they use calculator, it is weird. Anyway, how do we do that? By algebra. 8 is 3, 8 is 3, it's a common factor, right? I can just take this out, 8 is 3, and here we have 6, 7, 9 minus 69. And that's equal to 10, right? 8 is 3 times 10, that's equal to 830. And how about question B, 103 squared minus, how about 9? It is 3 squared, right? So, of course, if you don't know algebra, you have to square this and subtract. It will be quite long. But if you know algebra, what is it? Here we have 103 plus 3 times 103 minus 3, which is equal to 103 plus 3, it is 106. 103 minus 3, that is 100, which is equal to 10600. Okay, using algebra, even without any calculator, we can actually evaluate so fast.
Teacher, but can you do please like 901 multiplied by 899? Like when there's two numbers. I forgot how to do it.
Which one?
Like same thing as this, but there's only two numbers. Like 901 multiply, for example, to 899. Yeah,
Okay,
like
right. This one, also this 901, right? We can just write it as 900 plus 1 times, how about 899? We can write it as 900 minus 1. So now here we have a plus b, a minus b. So that's equal to 900 squared minus 1. What is 900 squared? That is 81000, right? And here we have minus 1. And we know how to subtract by 1. What is it? It is, what is it? It is 810,000, right? So this will be 89999.
okay, I understood.
Are you sure?
Yes.
Okay, good. I want to ask you some questions soon. All right.
Okay.
Uh, Rifa Ayan, Murat Ayan, second Ayan. Okay. Let's have break for 2 minutes. Okay. And also have some
Okay.
rest. If you can drink some
Okay.
water, drink, because now we are going to learn something special. You need some energy for this. Okay. 2 minute break. Also, let me drink 1 glass of water. I will be back soon. Okay, Ayan, Rifa, Murat, Ayan number 2, I'm back. If you're ready, let's continue.
Wait, but can I just call Aya number 2, please? Not call, just like tell her one thing.
Okay.
Because I don't have her number. Ayan. Ayan.
I think she is not here. She just entered and left.
Okay. All right. Okay, Murad, I have been using this Zoom for more than 2 hours. Now, altogether, how much is used? 763 megabytes.
Oh, but my megabyte's finished and I'm using my data.
Okay. So your one is too fast, I think. As I said, maybe it's different. But here in Cambodia,
Yeah,
especially in all this.
usually internet is like one of the best internets. Not one of the best internet. I think.
Where? Where?
Like in Asia, this China, Japan, they have the best internet.
No,
The best internet
In
in,
Cambodia,
in
we have the best internet in the world, I think.
no, best is in Hong Kong. Hong Kong goes.
You mean Hong Kong?
Yeah, Hong Kong. Yes.
Yes. 1 gigabit per second. That's so
Maybe. I
fast.
will see. I
Yeah,
will
that's
see. Also, I have students from Hong Kong. I have class to them on Sunday.
But
They
our internet is also first, but from the end.
Okay.
Of the
In this
beginning.
region, actually, internet is really fast. Very good. I mean, not only fast, it is fast and easy to get internet. Wherever you go, there's Wi-Fi so fast. And also one SIM card is free. And like I use like 10 gigabyte of internet for 1 week, it's just only $1.
Oh my god.
Like for example, for monthly, I will use how many? Like more than 50 gigabytes is I pay $8. 4G. And Wi-Fi in my house, it is free. Anyway, guys, let's continue. So now we are going to learn one important thing, okay? That's really important because we are going to see this a lot and you have to practice until you get comfortable with this. So what is quadratic expression? Now we will learn how to factorize quadratic expression. If you don't understand, you should practice as many problems as possible until you understand, until, oh, Mr. Qasim, now it is piece of cake for me, okay? Until you reach this level, you have to practice. So, okay, let's start now. What is a quadratic expression? Any expression of this form, ax squared plus bx plus c, we call this a quadratic expression, okay? So now we will learn how to factorize this. I'm going to teach you one method. There may be some different methods, but using this method, it is very easy. Just a little bit, you have to think fast. So actually, to do this one, I will consider two cases, okay? Number one, what is A? A is the coefficient of x squared, right? So suppose that A is equal to 1. If A equals 1, our expression becomes x squared plus bx plus c, right? In our second case, how about if A is not equal to 1, it is just ax squared plus bx plus c, okay? So now let me just consider the first case. Our first case is I am going to factorize this expression, x squared plus bx plus c, okay? Now suppose, just assume that I can factorize this. If I factorize, what does it mean? It means that here I will have something like this, right? Something times something, right? What does the something look like here? Rifa, actually, if it is possible, then these factors must be something like this, x plus p, and it should be x plus q. What are this p and q? I don't know. Now, if I expand this right-hand side, so what we have here, uh, we know how to expand this, right? X times x, that is x squared. X times q, that is plus qx. And p times x, that is px. And p times q, it is pq, right? So now, again, let me just simplify this. X squared Here we have qx, here we have px. What is a common factor? X is a common factor. So I can just write it as p plus qx and plus pq. Okay. So what we understand from here, it means that if we can find two numbers whose sum is, as you see here, what is p plus q? On the left hand side we have b, right? That p plus q is our b. On the left hand side, instead of c, on the right hand side we have pq. What is this? It is c. So can I find two numbers whose sum is equal to b and their product p times q is equal to c? If yes, then we can just factorize that algebraic, quadratic expression like this: x plus p times x plus q. Example, look, for example, let's say, let me just give you one example. Here we have x squared plus 3x plus 2, right? As you see here, what is the coefficient of x squared? It is 1, right? Because we have nothing, that's we have 1. So now, here we have our b is 3 and our c is 2. So can I find two numbers whose product is 2 and their sum is 3? What are those numbers? It is 2 plus 1 and the 2 plus 1. And this one is 2 times 1, right? As you see here, the same numbers, 2 times 1 is equal to 2. 2 plus 1 is equal to 3. That means that now I can factorize this expression as x plus 1 and the x plus 2. If you just expand this, you will get the same thing. X times x, x squared, x times 2, 2x, 1 times x, 1x, the year sum is 3x, 1 times 2 is 2. Another example, let's say here we have y squared minus 5x, minus 5x minus 6. Okay, so as you see here, not x, sorry, it should be y also, right? How do we factorize this? Can I find two numbers whose product is -6 and their sum is -5? Ayan Nagizade, can you tell me two numbers whose product is -6 and their sum is -5?
-5.
-6?
Oh, it's -6 and 1 just.
Yes, -6 times 1, -6 plus 1, right? -6 plus 1, it is -5. -6 times 1, it is -6. So we can factorize it as y minus 6. And here we have y plus 1. Another example, let's say here we have t squared plus 12t plus 20. Rifa, this question is for you. As you see here, that is a quadratic expression, right? Because it's in the form ax squared plus bx plus c. And what is the coefficient of t squared? It is 1. So can you tell me, can you find two numbers whose product is 20 and their sum is 12?
Okay, 20 multiplied by 1, for example, or 10 by 2.
Very
And
good.
6 plus 6.
No. Actually, those numbers must be the same. Two numbers whose product is 20 and their sum is 12. So that is
10
10
plus 2.
plus 2, right? Exactly the same numbers. As you see here, we are talking about P and Q, and P and the Q. So here, so I can just write it as T plus 2 and T plus 10. Ayan, is it clear? Ayan
Yes.
Nagizade. How about Murat? Are you there?
Of course, I'm here. I'm listening.
You're only listening, not watching?
I am watching. Like I can see your screen, and I do screenshots.
Okay, guys, you don't have to do anything. Just watch and try to participate in the class. All these notes, I save it. Okay, if you need it, I can save it and just share in our WhatsApp group. You don't have to
Sure,
screenshot.
mister. Please
Okay.
do.
Okay, just let me know. Okay, sometimes I may forget because I'm teaching a lot of different groups. Just Mr. Qasim, can you share the what is it? The slideshow. I'll just share with you. Okay.
Okay, Miss. Because like I want to repeat at home.
Good. All right, guys. I need more space. Just a minute, because we want to talk
Can we
about
just have a 10-minute break, please? I
2 minute
want to
break.
go to. Yeah, bathroom. I just need to go to the bathroom.
Okay. No, anyway, we are recording. You can go and come back. You can join us. No problem.
Okay. Just 2 minutes.
Okay, Rifa, let's continue. How about
Okay.
example 14? Here we have the coefficient of x squared is 1, right? So
Okay,
I'm
can I
just
say
going to use this method. So can you tell me two
can
numbers
you
whose
use
product is
red
12?
please?
Huh?
Okay. No, nothing.
Yes.
Okay. It will be 6 plus 2.
Yes, it is
6 plus
6
2.
times 2 and 6 plus 2, right? So we can just
Yes, I'm
factorize
saying,
it
can
as,
you use red, please? Red color. This color is a little not for me.
use what color?
I mean, can you red color, please?
Okay, I will use for you, but I don't like red color. Can I use a bit dark red color?
Okay, that's okay.
Okay. 6 times 2, 6 plus 2. This one is 6 times 2, right? So
Yes.
we can factorize it as x plus 2 and the x plus 6.
Yes.
All right. How about Aya Nagizade, question example 15?
6 and minus 1.
It is minus 6 times 1 minus 6 plus 1, right? I think we already did this, no problem. Minus 6 plus 1. So that's equal to x minus 6 and x plus 1. And Murat's, I think, there. Ayan, are you back? Where are you? Ayan. Okay, maybe she's busy. All right, let's continue. Rifai, again, it's your turn,
Okay, Miss.
unfortunately
I
or
came back.
fortunately. So can you tell me two numbers whose product is negative 6 and their sum is what? 1.
Whom are you asking? Rifa or me?
What is it?
Whom are you asking? Rifa or me?
Rifa.
Oh,
Okay.
okay.
Murat, are you
Um.
back?
Yes, I came back. I said I'm back.
Okay, Murat, you will be example 17. Okay, get ready. Yes, Rifa.
Okay.
Two
But
numbers, product is negative 6 and sum is 1. What is it? What are those numbers?
okay. Those not. Oh my God. Wait. I no, I don't know.
Ayan, Nagizade, any idea? So it is 3 times negative 2 and 3 plus
Ah,
negative 2, right?
okay.
So 3 plus negative 2 is 1, 3 times negative 2. So we can factorize it as x plus 3 and x minus 2. Murat, can you do example 17?
Yes, I think so. Okay, so um just a second. I need to think. Okay, so x.
No. Just tell me, Murat, two numbers whose product is negative 6 and their sum is negative 1. What are those numbers?
No, I'm sure. Like I solved in direct way. Wait, x minus 3. Yes. I solved
So
like
it
that.
should be x minus
Minus
3
3
and
and wait a second.
x plus 2. Look
X
at this.
plus
It's
2.
minus 3 and 2. X minus 3 and x plus 2.
Yeah. Okay.
Okay,
Like
guys,
I
now
need
we
to
will.
practice to make it faster, but I understood how to do it.
All right. Okay. So now we will talk about factorizing this one is not equal to 1. Let me just create one
Okay.
page.
Can you please say how many questions do we have on PR?
Say again.
I mean, can you please say how many questions will we have in Olympiad? Like, if not exact, around what number or approximate?
Rifa, look, you should not hurry. We will practice all past papers, okay? It's about, let me just show you one. I can show you one. You are grade 8, right? Okay. Now you can see my screen. Okay, let me just show you one question. 14, for example. You are grade 8, right? Are you grade 8?
Yes.
Okay,
Yes.
that means you are primary, secondary 2. Okay, that's one sample question. Even I can send you, you can have a look. Because after finishing maybe 5 chapters, then we will start solving SASMO questions. So here we have questions altogether. We have how many questions? 25.
Mm-hmm.
Okay. So 25. It may change, maybe 25, 28, 30, around this many questions. Okay. So these are the questions, but usually questions are a bit tricky questions. Just knowing is not enough. For example, Rifa, can you read the first question?
The first day of 2014 was a Wednesday. There are 365 days in 2014. I mean, 20, yes, in what a day of the week will 2015 begin? It will be Thursday.
Okay. Thursday? How do you know that?
Like every year, like one day it goes after.
Very
I
good.
don't know how to explain it, but I know that it's like that, no?
So this 7, right? We should just divide this by 7. It is 2, 8, 85. It is 84. You are right? Because how do we know that? Because this 365, right? 365. When you divide it by 7, the remainder is 1. That's why, for example, today, if 1st of January is Friday, right? Is it Friday? Yes, Friday. So next year, the 1st of January will be Saturday, right?
Yes.
And next year it will be Sunday. Next year it will be, of course, if I ask you like this, how about this year? Let's say, suppose that it is in 2016. Okay, and the 1st of January is, let's say, it is Friday. What will be, in what day of the week will 2017 start or begin?
Say again, please.
Okay, now we are in 2016. Okay, and the 1st of January of
Okay, okay.
2016 is Friday. Okay, what will be the 1st January of 2017? What day will it be?
Saturday.
It will be like day after Sunday. I mean Friday, day after Friday. It was Sunday, yes, Sunday. No, not Saturday. Saturday.
Saturday. Ayan, how about you?
Me or
Ayan Nagizadeh, what's your answer? Do you agree with Rifa?
yes.
Murat Seyedzadeh, how about you?
Yes, mister.
Okay, but you are all wrong. You know why?
It's not
Because
Saturday.
in SASMO, actually, they ask this kind of questions.
Not
2016 is,
Saturday. Not Saturday. Thursday.
no, the answer is Sunday.
Why?
Why? Because in every year we have 365 days, right?
Mm-hmm.
And how about in leap year?
Oh, that's genius. Oh my god.
Because in 2016, in February, we have 29 days. In 2020, for
Oh,
example, we have 9 days, 29 days in February. Only in
okay.
leap year, that's why it starts not Friday. It starts actually, I mean, the first day of 2017 will be Sunday.
Sunday. Yes, Sunday.
You know, in SASMO, they ask this kind of tricky questions. Let me ask another question here. For example, okay. Ayan Nagizade, can you read the question?
What is the maximum number of parts that can be obtained from cutting a circular cake using 3 straight cuts?
How would you cut this?
But how you can do the straight cuts? No, okay, no. It will be four? Four, yes.
Yeah, you have a knife, for example, you have to cut this, right? And what is the maximum number of parts that can be obtained from cutting a circular cake using 3 straight cuts? Straight cuts.
But it can't be straight cuts.
Diagonal is also straight.
Oh my, I don't think that it's four because it's a little, I think it's tricky.
5?
You know, how it be actually it is 4. Because if you cut like this, maybe I need to reopen this, right? If you just cut, right, it will be 6 pieces, right?
Yes.
But I can cut this into more than 6 pieces just using 3 straight cuts. Like, for example, let me just draw this here. Okay, we are talking about this kind of cake.
Okay.
Okay. 3 straight cuts. I don't know. I'm just thinking. I'll just cut from 1 from here. Okay. How many pieces do we have here? 2, right? Now I cut from here. Now how many cuts? 4. Right? And how about if I cut here? Now from here, if I cut from here?
Oh.
How many?
8.
8 pieces, right? So we can cut actually in 8 pieces. The maximum number is 8. I don't know if you can find more than 8, let me know. Anyway, I mean, you are going to solve this kind of question, but just wait. Okay, now we have to actually learn 3 more chapters. Then we will practice SASMO questions. Still, we have time. Okay, when you practice
Mister,
1 or 2.
we have
Yes.
7 minutes.
Yes. Okay. No problem, Rods. Anytime you can leave. Okay.
No. I'm not. You're just saying we have time, but like we don't have time.
No. I mean, we have time until SASMO exam. I mean.
Ah, okay.
Okay, because SASMO is in April, right? We have around 4 months. But 1 month, we have to study topics, maybe 2 months. Then maybe 2 months, we will practice SASMO questions. I mean this, okay?
Okay.
Okay, guys, let me just do something and we will finish the class.
Okay.
We were talking about quadratic expression. Now we will consider the second case where a is not equal to 1. At that time, our expression becomes something like this, right? Ax squared plus bx plus c. Now, because of this a, if we factorize this, we will have something like this. Here we have mx plus p, okay? I'm saying that if factorization is possible, then the factors must look like this. I'm just, predicting this. Here we have nx plus q. It must be in this form if we are factorizing this, okay? Now, so I'll give you a lot of examples. You understand why I mean, so now if I expand the right hand side, what do we get here? Mx times nx, that's equal to mnx squared. And mx times q, right? What is it? It is plus mqx. And p times nx, that is plus npx. And p times q, that is p times q. Now, as you see here, these two terms, they have a common factor of x. So I can just reorganize and write it as mn x squared plus, here we have mq, and here we have np, and here we have x. And here we have pq, okay? Now, if you notice here, what are these nq and np, okay? So if, for example, ax squared plus bx plus c, can I just find 2 numbers whose product is 8? That is, let's say it is mx and nx. Also, can you just find 2 numbers whose product is c? So let's say it is p and q. in such a way that we have another condition. When I cross multiply these terms, okay, when I cross multiply these terms, here we have nx times p, that is npx, mx times q, that is mqx, right? And there is sum. If you add this, what we have here, n mq plus npx. What is it? It is just the middle term. Okay. So if it is so, then we can factorize it in this way. Guys, it may be a little bit hard for you. Okay.
No,
Now
it is.
I'll just explain this in examples. For example, let's say here we have, what I'm saying here is, let's say 2x squared plus 7x plus 3. Okay. So now the only way to write 2x as a 2x squared as a product of two numbers is 2, because 2 is a prime number. So let me just write it as 2x, and here we have x. How about 3? Now I should actually factor this 3 in such a way that when we cross multiply, we should get 7x. What is here? I can write it as 1 times 3. 2x times x, 2x squared. 1 times 3, that's equal to 3. If you cross multiply now, if you cross multiply, x times 1, that is x, 2x times 3, that is 6x, and the sum is 7x. Does it give us the middle term? Yes. Then
Yes.
I can factorize it like this: 2x plus 1, 2x plus 1, and the second one is the second line, we have x plus 3. So here we have x plus 3. Now the second example, for example, here, 3x squared minus 17x plus 20. Okay, so again, this 3 is a prime number. The only way to write a prime number as a product of two numbers, what is it? 1 and itself. So I can just write it as 3x, because when it's a prime number, it's quite easy. So now 20, I should actually factor 20 in such a way that when we cross multiply, it should give us minus 17. What is this? As you see here, it is minus 17. So 4 and the 12, right? It is 5, 12. Okay. So I can just write it as 5 and here 4, right? And but here it is minus 5, minus 4. But make sure that when you just multiply these numbers, we will get these terms. 3x times x, 3x squared, no problem. Negative 5 times negative 4, that's equal to positive 20, no problem. Now, if you cross multiply, x times minus 5x, that is minus 5x. 3x times minus 4, that is minus 12x. If you add these two things, what is it? Here we have minus 17x. Is it equal to the middle term? Yes. Then I can factorize it as, what is it? 3x minus 5, and here we have x minus 4. Now you can check this. If you just expand this, you will get that quadratic expression. Some more examples. Okay. Let me just do only one. All right. Question A, and I will stop teaching here. I know you are tired. X squared minus 16. How do you factorize this? That is x squared minus, here we have 4 squared. That is x minus 4. And here we have x plus 4. Okay, guys, let me stop here. Rifa, Ayan,
Okay, mister.
Ayan, I wish you happy new year. Okay, and I will meet you
Thank
next.
you, mister. Thank you. Goodbye.
Tomorrow and Thursday we don't have class. Enjoy your holiday, and see you next week. If you have any question anytime, you can write to me from WhatsApp. Okay.
Teacher, you said next week.
Okay, mister. Bye.
Yes, bye-bye, Murat. Tomorrow is 31st of December. We don't have class. Friday, 1st of January, also we don't have class, okay?
Oh,
Because
okay.
it is last day and first day, so we cancel the class. We will continue next week.
Okay, teacher.
Okay, mister. Bye.
Okay, Murat,
Okay.
bye-bye. You can leave, no problem.
Happy
And
New Year.
Ayan, one thing for you, Ayan Nagizade. If you are if these questions are too easy, I suggest you to practice a little bit more challenging question. At the time you improve your math. If you know something, practicing again and again, it doesn't improve your math. Okay. If you need more challenging questions, or if you want to practice some more questions, just let me know. I will send you. After you finish one paper, I will give you more paper. In this way, you can improve much faster. Okay.
Okay.
All right. Good. Thank you very much. Have a nice weekend. See you next week. Okay.
Goodbye. See you.
Bye bye. Bye bye. Thank you.